Plane turning is the shopman's term for one of the most important of all operations performed on the metalworking lathe, the machining of straight cylindrical work between centers. Whenever possible, work should be mounted between centers because heavier cuts can be taken when both ends of the work are supported. As the work revolves, the cutting tool on the lathe carriage, guided by the V-ways of the lathe bed, moves in a straight line and cuts off the surface of the rough stock to produce a true cylinder. Although this appears to be a simple operation, there are important rules that must be observed if an accurate cylindrical shape is to be produced. The operator works from a blueprint which shows him the exact size and shape of the part to be made, which in this case is a steel shaft. It is 2 inches in diameter and 12 inches long. One end is machined to a 1 1/2 inch diameter for a length of 4 inches. Before the work can be mounted between the lathe centers for machining, center holes must be accurately located and drilled in each end. The ends are chalked to facilitate marking. The center head of a combination set is placed firmly against the shaft. A sharp-pointed scriber is used to draw a line across the work. Placing the center head at right angles to its former position, the operator scribes another line which crosses the first line at the center of the work. This point is marked with a center punch. The center punch is held vertically and tapped lightly with a machinist's hammer, checking between each blow to make sure the mark is properly located. For drilling the center holes, a combination center drill and countersink is used. It is held in a drill chuck. The shank of the chuck should be cleaned before it is inserted in the headstock spindle. Placing the drill chuck in the headstock spindle, the operator prepares to drill the center holes. The spindle should run at about 180 revolutions per minute for this operation. The work is held in the left hand with its right end supported on the tailstock center. Oil is used on the point of the drill to make it cut better. As the tailstock hand wheel is turned, the center hole is drilled into the end of the shaft. The drill must not be crowded or the point may be broken off. When one end is finished, the other end of the shaft should be centered by the same method. It is important that the holes be drilled to the right depth. If drilled too deeply, they will not fit the center points. On the other hand, if they are too shallow, there will not be sufficient bearing surface. After the center holes are drilled in the work, a lathe dog of suitable size is selected and attached securely to one end of the work. When attaching the lathe dog to a shaft, it should be adjusted carefully. The screw must be tightened firmly to make sure that the work will not slip when heavy cuts are taken. Before the headstock center and faceplate can be mounted on the lathe spindle for machining the shaft between centers, the drill chuck must be removed with a knockout bar. The long taper of the headstock center should be wiped clean so that the center will run true when placed in the spindle. Chips on the center may also damage the taper of the spindle sleeve. The threads of the faceplate also are carefully cleaned to remove metal chips and dirt before it's put in place so that the spindle threads will not be damaged. The spindle nose threads should be cleaned and oiled before the faceplate is attached. The lathe dog on the work will be driven by the faceplate. A drop of oil is placed in the tailstock center hole before the work is mounted in the lathe. Dry red lead mixed with machine oil is a good lubricant for this purpose. The tailstock is moved to the correct position and locked in place by tightening the tailstock clamp bolt. The end of the work is placed on the headstock center, and the bent portion of the lathe dog is placed in the slot of the faceplate. The tailstock spindle is advanced by turning the tailstock hand wheel. It is adjusted just tight enough to eliminate looseness or play between work and centers, but not tight enough to bind. When properly adjusted, the tailstock spindle is locked in place by the tailstock binding lever. Considering the type of cutter bit, the kind of metal, and diameter of the shaft, the correct cutting speed for this 2-inch hot-rolled steel bar is approximately 180 RPM. The ends of the shaft should be faced square before turning the diameter. For this operation, a facing tool is used. The facing tool is a steel cutter bit properly ground for the facing operation. It is inserted in a straight tool holder. The tool post is placed on the compound rest. Its ring and rocker are assembled. The rocker permits the cutting edge of the tool to be set at different heights. The cutter bit and tool holder are drawn back in the tool post to eliminate unnecessary overhang. This provides better support for the tool and eliminates chatter caused by the tool springing. The facing tool is adjusted in the tool post so that the cutting edge is the same height as the tailstock center point. To prevent the carriage from shifting when the facing cut is taken, it is locked to the lathe bed by tightening the carriage lock screw. Turning the cross-feed and compound rest ball crank simultaneously, the operator sets the tool to start the cut at the tailstock center. If pushed against the center, the tool's sharp tip would be broken, so care is necessary. For facing the end of the shaft, hand feed is used for the cross slide. Just enough stock is removed from the end of the shaft to produce a smooth, accurate finish. One or more cuts may be taken as required. When the facing operation is completed, the cutter bit is removed from the tool holder. According to the blueprint, the shoulder is to be machined 4 inches from the end of the work which was faced by the operator. The hermaphrodite calipers are carefully set to the 4-inch mark on the scale. The operator measures the 4-inch length on the work. Then he chalks the shaft before scribing a line where the shoulder is to be machined. Holding the hermaphrodite calipers against the revolving work, a fine line is scribed to indicate the position of the shoulder. The diameter of the work to the right of the shoulder will be reduced by the next operation, rough turning. This cutter bit is ground to the correct shape and with the correct clearance and rake for taking a roughing cut. The point of the bit is slightly rounded. The cutter bit and tool holder are drawn back in the tool post. The cutting edge in this case is set about 5 degrees above center. When the tool is properly set, the tool post screw is tightened to hold the tool securely in position. From the blueprint, the operator learns that the shaft is to be finished 1.5 inches in diameter. Outside calipers must be set to the correct size for measuring the roughing cut. In this case, the operator sets the calipers 1/32 of an inch larger than the specified diameter, or 1 17/32 inches. For this roughing cut, nearly 1/4 of an inch deep, the operator selects a medium coarse feed. The feed is approximately 7/1000 of an inch for each revolution of the spindle. The operator starts the lathe and advances the tool by hand for a trial cut, being careful that it does not cut too deeply into the work. The automatic power longitudinal feed is then engaged. The trial cut is taken just far enough along the work to permit testing of the diameter with the calipers. Then the feed is disengaged and the lathe is stopped. Carefully measuring the diameter without forcing the calipers, the operator finds it's a little too large. For another trial cut, the cross-feed ball crank is turned to move the cutting tool in a few thousandths of an inch. The micrometer collar is graduated in thousandths of an inch to guide the operator in setting the tool for the exact depth of cut required. The operator takes as many trial cuts as are necessary to obtain the desired size. He now finds that the cutting tool is correctly set for rough turning to the right diameter. The automatic power longitudinal feed is then engaged and the tool is allowed to travel the full length of the cut. As the work is machined and the tool cuts away the steel, the shaft gets hot and expands, which, if allowed to continue, will cause the work to bind and damage the tailstock center. When machining a long shaft between the lathe centers, the experienced operator occasionally disengages the feed and stops his lathe to see if the work is binding between the centers because of expansion. If the work has become too tight on the centers, it is relieved by readjusting and oiling the tailstock center. Scribed line indicating the position of the shoulder, the automatic power longitudinal feed is disengaged. The tool is then fed by hand almost to the scribed line, allowing about 1/32 of an inch for finishing the shoulder. When the roughing cut is completed, the rough turning tool is removed from the tool holder. The tool for finish turning is similar to the rough turning tool, except that it is ground with a slightly larger radius on the point. The cutting edge of the finish turning tool is honed with a small oil stone to increase its life and to give it a keen edge which will produce a smooth, accurate finish. For the finishing cut, the tool is adjusted so that its cutting edge is set about 5 degrees above the center axis of the shaft. For finish turning, the quick change gearbox is arranged for a fine feed which will produce the desired finish. The lathe is started and the tool is fed carefully by hand into the start of the cut. Automatic power longitudinal feed is then engaged and a cut is taken just long enough for measuring with a micrometer caliper. The lathe is stopped so that the operator can accurately measure the diameter of the trial cut with the micrometer. The diameter is found to be a little oversized. The operator feeds the tool in a few thousandths of an inch, and another trial cut is taken on the work. After the second trial cut has been taken a short distance, the lathe is stopped and the finished turn diameter is carefully measured again. The operator now finds that the cutting tool is set to finish the shaft to the exact diameter shown on the blueprint. Taking a light cut at a fine feed, the keen edge of the finish turning tool produces a smooth, accurate finish on the surface of the work. When the cutting tool approaches the shoulder, power feed is disengaged and the cut is finished to the shoulder by feeding the carriage by hand, as the operator did in rough turning. Now that the finish turning operation is completed, the turning tool must be replaced with a tool especially ground for finishing the shoulder and for machining the clearance groove or neck. This tool is similar to a facing tool, but its point is ground to the correct width and shape for machining the 1/8 inch clearance groove next to the shoulder. The left edge of the tool will finish the shoulder. The operator sets the tool in the proper position by placing the left edge parallel with the faced end of the shaft. The tip of the tool, which will cut the neck, is set at the same height as the tailstock center point. When the tool has been correctly adjusted, it is locked in place in the tool post. The carriage is then moved to the shoulder for the facing cut, and the carriage lock screw is tightened to hold it in place. The neck is to be machined to a diameter of 1 7/16 inches. The operator sets his calipers to that dimension as specified in the blueprint. Feeding the tool by hand, the operator faces the shoulder to the line scribed on the steel shaft, and the neck is machined to the correct diameter, 1/16 of an inch smaller than that of the finished shaft. The lathe is stopped and the diameter of the neck is checked with the calipers. The operator finds the neck is a little too large and another cut is taken to bring the diameter to the correct size. The job is now finished and the work is removed from the lathe. Many of the operations required to make this simple shaft are the same as those used on more advanced work, regardless of size or design. Some of the operations we have seen, such as locating and drilling center holes and taking measurements, may be done in several practical ways. Some of these, as well as other more advanced operations, will be demonstrated in companion films in this series.